I welcome you all to this class. In this lecture, we are going to discuss about the engineering mechanics. This class is totally the fundamental that we will learn that what are the system of forces and how to find the component of the forces, right? And that is how to get the compositions, how to resolve the forces, right? As well as some problem we will discuss, and also we will learn the Lami's theorem. So first of all, we'll start with what is a system of forces. So it's very means basic that by name itself you can understand that what is system of forces. So system of forces is what? That system of forces is nothing but that when several forces of different magnitude and directions act upon a body, they constitute a system of forces. Means that you have a number of forces is there, okay, and these number of forces is having different magnitude in the sense that they're different values and they have a different directions, right? And they are acting on a body and constitute system of forces. So let's say that you can write on this definition when several forces of different magnitude and direction act upon a body, right? They constitute, we can say they constitute system of forces, right? System of forces. So how you can show that system of forces is what? And suppose you have a one force is like this of magnitude f1 and the direction is how? It is horizontal rightward direction. Suppose another force of having magnitude is f2, these values are different, and how it is acting? This is acting towards the left horizontally. Let's say this another forces which is having magnitude is f3, it is vertically up, and let's say another force which is f4, and this is what inclined, okay, which is going towards downward direction towards left, right? So such forces, they constitute we call it as a system of forces, right? After system of forces, we need to see that what is the composition of forces, right? So next you can write composition of forces, okay? Very basic we'll learn first composition of forces, okay? So composition is means what? The composition is nothing but the process of finding out the resultant forces is called composition of forces, right? So resultant means what? The resultant is nothing but the single force, right, which is having the same effect which act on the different means when the different forces are acting, right? So composition of forces is nothing but we can say the process of finding finding out the resultant force is called composition of forces, right? Composition of forces. So it is just you can say that composition is nothing but the method, right, by which or how you can find out the resultant. So the main thing is that we need to know what is resultant actually, right, and how to get the resultant. So resultant is we can denote it by R, okay? So first you can say that how to get the resultant. The resultant is nothing but to find a single force which will have the same effect as that of the number of forces acting on a body. So resultant is nothing but the one force which is having same effect of number of forces which is acting on a body. So let's say this example, that is system of forces we have taken. So in this system of forces you have a 4 force, 1 2 3, that is F1 F2 F3 and F4, right? So when we find when you convert these 4 forces into single force, that single force is called as a resultant of these forces, right? And that resultant is having same effect, whatever the effect is creating on this on the system by these forces. Okay, so resultant is what? Resultant is nothing but you can say to find a single force which will have the same effect, as that of number of forces, as that of number of forces, right? Acting on a body, right? Okay, so to find a single force which will have the same effect as that of number of forces acting on a body. So this is what it's just a definition, but what is the mathematical expression to find out the resultant? So for resultant you have R, and R we can find by root over of summation of f x square plus summation of fy square. Okay, so this is the formula or equation by which you can get the resultant. Now what is the summation fx? So your summation fx is nothing but summation fx is the sum of all horizontal forces, right? Sum of all horizontal forces, right? And summation of fy is sum of all vertical forces, right? Sum of all vertical forces. Okay, now after this, that it means that whenever the system of forces is given, from that system of forces, if you convert that system of forces into single force, it is the resultant. Then the question is arising how to means summation you have to find, means you need to resolve them, right? So now we will see the resolution of forces. So resolution of forces is nothing but the it is just opposite of the composition of forces. So composition of forces means what? Composition of forces is the the process of finding the resultant. Is it or not? It means, and the resultant is what? The resultant is a single forces which will have the same effect, okay, as the number of forces which act on the same body. So resolution means what? The resolution means there is a one force and then you are converting this into their component. Component means what? That if the force is inclined, so you need to find out their component on x as well as on the y. So let's say that you can write the topic is resolution of yes, that is resolution of forces. Sorry, this red color is not showing properly. Resolution of forces. Okay, so this resolution of forces means what? That see this, if I ask you that one force is there whose magnitude is f. Force is a vector quantity, so you can show the vector notation, it will be better. So this force f, how its direction? The direction is horizontal right. It means that the f magnitude of force in this case is not acting on the vertical, it is only act on the horizontal. So next force is, let's say it is like this, right? The magnitude of, you can say f only. Okay, so how it is acting? This force is acting towards the left and horizontal. Okay, now if the force is like this, and let's say that magnitude of this force is also f, you can use p also, no problem. So this is acting vertically up, And if the force is like this, how it is acting? It will act vertically downward. It's very clear that in horizontal, in this way, the force is not on vertical, not on horizontal, not on vertical, not on horizontal. It means it's pure horizontally, it's a pure vertical, it's a pure horizontal, and it's a pure vertical. Right? Now, what if one force is like this? So let's see that. What if one force is like this? Okay, so you can see this force is inclined. So whenever the force is inclined, it means that we need to resolve them. Resolve means what? We have to find out their component. So component you can get on x-axis as well as on the y-axis. So as you know, this force is inclined. Okay, so the question is arising that the inclination with what? Maybe the inclination with the horizontal plane or with the vertical plane. So let's say this is your x-axis and this is the y-axis. So you can show it that this is your x and this is your y, right? And the force, this is inclined force whose magnitude is F. And let us say that in this case this force F is inclined with the horizontal with an angle of theta, right? So as the force F is inclined, so whenever the force is inclined, which means that we need to find out their component along x-axis and the component along the y-axis, right? So what is that? So component along x-axis, fx is equal to f cos theta, okay, and fy is equal to, that is, f sin theta. This is what? This is why? Because that cos and sin is came in this case only when the inclination with the horizontal. If the inclination with the vertical, that this will be reversed. Let's say that here I'll tell you that how it came. Okay, now just wait. That here, that this is your x and y plane. This is your x and this is the y plane. All right. Okay. So the force is inclined. And the magnitude of the force is F, and this time we are taking the inclination with the vertical, right, with this angle of theta. Okay, so in this case that the component will be reversed. That means the horizontal component fx is the f sine theta, okay, and vertical component fy is equal to f cos theta, okay, fy is equal to f cos theta. How it come? Let's say that, see, so if this is the angle, it means that this axis is for your vertical component, that is fy, and this axis for the horizontal component. So now if I draw one line which is parallel to the x-axis, in this case when the inclination with the vertical, so you can see this one triangle is there, right? In this triangle, this is your opposite, right, and this is your adjacent, right? We need to know the relation. That F we already know, this is your hypotenuse, right, the inclined force whose magnitude is given actually. So if I want to know the y component, that is fy, so fy means what? We have to get the relation of fy and f. So this is your adjacent and this is your hypotenuse. So what is the relation between adjacent and hypotenuse? That adjacent and hypotenuse is nothing but the cos theta, right? So cos theta is what? That is adjacent, right, by hypotenuse, right? So adjacent is what? That adjacent is nothing but you have to find fy, and the hypotenuse is given, that is f. So what is the fy component? That when you cross multiply this, when you cross multiply, that fy is equal to f cos theta. All right. Okay. Similarly, if you want to know the horizontal component, right, so the horizontal component means what? You have to find this and this relation you need to get. So this is what? Opposite, and this is the hypotenuse. So what is the relation between opposite and hypotenuse? That is sine theta. Very good. So you can say the sine theta is equal to what? Sine theta is equal to opposite by hypotenuse. Okay, and opposite is what? That opposite is fx in this case, when the inclination with the vertical, and this is the f. So when you cross multiply, you'll get, sorry, again it is smaller, right? So fx is equal to f cos, sorry, I'm very sorry, that f sine theta. All right. So right, see, sometimes it's blurred right now. Now in this case, I hope you understood, but again I can show you that this is the inclination with the horizontal, so you can draw the line vertically which is parallel to the y-axis. So this is your opposite, and this is the adjacent, and this is the hypotenuse. So whenever you have to find out the let's say that x component, okay, so when you have to find out the x component, that means this, right? So this is your adjacent, and this is the hypotenuse. So adjacent and hypotenuse is what? Cos theta, right? So cos theta is equal to adjacent by hypotenuse. So adjacent is your nothing but fx in this case, and this is the f. Cross multiply, you will get the fx is equal to f cos theta. These things you have studied in your trigonometric in the 10th standard, right? And sine theta is equal to, just for the, as I told you at the beginning of the class itself, that is the basics. So we have to discuss sine theta is equal to that is opposite by hypotenuse, means fy by f. Okay, so fy is what? Fy is equal to f sine theta. So this is how we will get the resolution, right? So resolution definition is what? That it is a exactly opposite to the composition of forces, right? In which that is the process of finding the number of component, right? So resolution of forces in simple language, right? That in one paragraph you can say that it is a opposite to the composition of forces. It is a opposite to the composition of forces, right? To the composition of forces, right? That is the method to find the number of component, or you can say that the method, right? Short notes you can write. Method to find the component of forces. Component means what? X component and y component of forces, right? Okay, now that this is over, so that first you see that coordinate system, it's just a basic that sometimes we need not to go in that much of basics, right? So resultant we have discussed, the formula I told you already. Then we need to find one more thing, that's direction of the resultant, right? That is direction of resultant, right? Now, so direction of resultant, how you find that? Tan theta is equal to summation of fy by summation of fx, or theta is equal to tan inverse of summation of fy by summation of fx. So this is what you have, a theta is equal to tan inverse of fy by fx, right? One simple problem we will discuss, that is very fast you will write, that determine that, let's say not just we have a one system of forces is given, that you have a one problem is there, that the forces is like this, right? This is one system is there, this is one hook, this is your x-axis, and this is your y-axis. It is shown in the figure like this, right? The three forces are acting actually. One force is like this, and one force is another like this, and one force is like this. These are the three forces is given, and all these three forces are inclined actually. So when it is inclined, it means its component is 80 Newton, force is magnitude, and its magnitude is 70 Newton, right? And its magnitude is 50 Newton, right? The inclination with the horizontal, this is your x and this is your y, this is your x-axis, okay? Now, so the forces is this and this one. Again, the angle between these two forces is for the 25 degrees, and this is also 25 degrees, and this inclination is 45 degrees, right? So there are the three forces, and all these three forces are inclined. So you need to find out the resultant. The question is find the resultant. Find the resultant and directions, right? It's very basic, very fundamental type of problem. Simple, right? So anyone can do. So you have a solution here, that let's say it is the solution, right? So first you have a three forces is there, that 80 Newton, 70 Newton and 50 Newton. So these three forces are inclined with 25, 25 and 45. So we need to resolve the forces. So we can say that resolving the forces horizontally. Okay, resolving the forces horizontally, right? I'm sorry that my handwriting is not good because we are writing fast. So this is summation of fx is equal to what? 80 Newton inclination with the 25 degrees, and this arrow is like this, so this will goes towards the right. So right side horizontal is positive, so it will be 80 cos 25 degrees. All right, then again this is 70. See the angle, the reference is this x, so you have to always, you need to measure the angle from the reference plane. So reference plane for this force is what? That this x-axis. So the total angle is what? 50 degrees, right? So again the arrow is like this, so horizontal component will goes towards the right side, horizontally right. So it is what? Plus 70 cos 50 degree, right? And again this third force is inclined with 45 degrees horizontal, so its horizontal component will goes towards the right. That is also positive, so you can say plus 50 cos 45. Okay, so you can put in the calci and get the values. I'll later on will write. So or you can, yes, wait. So next we can say the resolving the forces vertically, right? Vertically. So resolving the forces vertically means what? Summation of Fy. See this force is what? This force is 80 Newton, horizontal inclination 25. So vertical component is what? 80 sine 25. Vertically up it goes positive. 70 Newton, total angle is 50. Its vertical component is vertically up positive. 70 sine 50, and it is actually it's like that. So it means that it will goes downward. So downward means what? Negative. So you can write down the component for this, that is resolution, that 80 sine 25 plus 70 sine 50 degree minus y, because vertically downward, 50 sine 45. All right, so then you can put in the calci and get that answer. So you have a 80 cos 25 plus what is this, 70 cos 50 plus 50 cos 45. So this value is 152.85, right? So it is 152.85. It is given in Newton, and this will be the 80 sine 25 plus 70 sine 50 minus 50 sine 45, right? So this will be the 54.83 Newton. So this is summation x and summation Fy we got. Now you know the resultant formula, that here only the resultant R is equal to root over of summation of fx square plus summation of fy square. So directly I'll put the values and showing the answer, that root over of fx is what? 152.85 whole square plus 54.83 whole square. So this your answer is 162.38 Newton. So what is that? Actually we see the composition, right? So we have the system of forces is given, that 1 2 3 forces, and they are acting on one plane or one point, so it is coplanar and concurrent. So first of all we have to find out the resultant. Resultant is what? Method of finding the single forces. So single forces will got, this is 162, this is the single forces. From where? From system of forces. First, for finding the single forces, we need to find out their component. That component along x, y will got, right? Summation we did. Then direction also they ask. So here you can simply find out the direction. Sorry. So this is what? Directions, right? So direction is what? Tan theta is equal to summation of fy by summation of fx. So theta is equal to tan inverse of fy is what? That I think 152.85 and 50, yes, 152.85 by 54.83. So this theta inverse, theta will what? Is it not right? So now, so this is what you can say, tan inverse of 152.85 over 54.83. Sorry, right? So theta is equal to 70.26, means your resultant is at the angle of 70.26 degree, and the resultant has came positive, it means that it is vertically up only, right? Arrow is up. So this is how we will solve the problem. So in next class we will discuss the Lamy's theorem, as well as we'll do the problem. So for more update, please subscribe the channel. Thank you.